So this is a question on the test review. So this is covering something from the normal distribution chapter, normal model. So um, let's read through this. So agricultural scientists are working on developing an improved variety of a breed of tomatoes. Marketing research indicates that customers are likely to bypass tomatoes that weigh less than 75 grams. The current variety of tomatoes produces fruit that averages 80 grams, but 13% are too small. It's reasonable to assume the normal model applies. What is the standard deviation of the weights of tomatoes now being grown? So in order to do this, we're going to start with the normal curve just to kind of see what's going on. Might not be completely necessary to draw it, but I think it does help. So it says average is 80 grams. So the 80 grams is going to go in the middle. That's our mean. And then they're likely to bypass tomatoes that weigh less than 75. And then 13% are too small. So if we go over here to 75, we know that 13% are going to be below 75. Now, we can find the standard deviation from that by using the z-score. And to find the z-score, we just need to basically change this into a standard normal model. So the standard normal model is a normal model with a mean of 0 and a standard deviation of 1. And the way you can find the z-score is you can do an inverse norm on your calculator. 13% is to the left, and then you can just leave it. You can either leave that blank if you don't have the menu that comes up when you get to the inverse norm page or screen, or you can put 0 for the mean, 1 for the standard deviation. So when you do that, you get negative 1.126. So that what that is telling us is that is a z-score that relates 75 to 80 with whatever the standard deviation is that we're looking for. So we want 75 to be 1.126 standard deviations below 80. All right, so now if that's our z-score, we can find the standard deviation. So if you recall, the z-score formula is the data point minus the mean divided by standard deviation. And so we know all these except for the standard deviation. So the z-score is the negative 1.126. The data point is 75. The mean is 80. And then we're looking for sigma. And so you can just cross multiply, divide by the negative 1.126. And then we get that the standard deviation is 4.44. All right, and then you can test this. You can check to see if this is correct, and you can do a normal CDF where you're going from 0 to 75, mean of 80, standard deviation of 4.44, and see if you get 13%, roughly 13%, because this is not going to be exact, but roughly 13%, and that should work out. So then the next part, scientists hope to reduce the frequency to no more than 4%. One way to accomplish this is to raise the average size of the fruit. If the standard deviation remains the same as in part A, what is the target mean? So now we're going to kind of do the same thing, but we're going to change this to 4%, and then we're going to use the standard deviation we found, and now we're going to look for the mean. So it's a similar problem, but we're looking for something a little bit different. So again, you may not need to necessarily draw the picture, but it definitely helps. So we still have the 80 and the 75, but now we want this area to be 4% instead of 13%. So now we need to find the z-score where 4% are less than 75. So we're going to do the same thing, but now we're going to use 0.04 standard normal model. So we're going to let mean be 0, standard deviation be 1. And then when we do that, we get negative 1.751. So now, so there's our z-score. So we want 75 to be 1.751 standard deviations below the mean. And actually, I guess technically we're not using that. We'll just put that there. So that we don't know the mean is 80. We're finding the mean. So again, using the z-score formula, so we have negative 1.751 equals 75 minus the mean over, and we're going to use this standard deviation again, using the same standard deviation as in part A, so 4.44. And then I won't work through the algebra, cross multiply, subtract 75, and then that would be negative mu, so then just change the sign. And we get that the new mean is 82.77. So again, same basic idea as part A, but now we're looking for the mean instead of the standard deviation. And then part C says the researchers produce a new variety with a mean weight of 79, which meets the 4% goal. What is the standard deviation? And so now, again, draw the curve. And 79 is the mean, and 75, and we have 4% under that. And so we know that the z-score such that 4% or below, whatever the data point is, where 4% or below, the z-score for that data point is negative 1.751. So that's what we did in part B. So it'd be the same thing. You can do the inverse norm, you get the same thing, obviously. And so now we're looking for the standard deviation. So 75 minus 79 over the standard deviation, solve for sigma, and we get the sigma is, and I did not write it down. So let me do that real quick. 2.28. So that is a standard deviation. If the mean is 79 and 4% or below 75, then the standard deviation must be 2.28. So all of this is kind of based on it's a normal curve, and we can kind of mess with the mean, mess with the standard deviation, and see where do we need to put those at so that 4% or whatever percent we want are below 75 in this case. And then the last thing, based on their standard deviations, compare the tomatoes produced. And so all you're doing, compare the standard deviation in part A, 4.44, with standard deviation in part C, 2.28. And so all that tells us that the new tomatoes are more consistent compared to the old tomatoes because the standard deviation is smaller, so the spread is going to be smaller. So that means that you're consistently getting more around the mean, and so you get less that are subpar. Okay, so hopefully that helps with that one.